Okay, class, welcome back to the real life. So, what we will do, since you have your test one on Wednesday, this Wednesday, today, my plan is I will go through briefly about the topics. The best way to do is I will go through all the practice problems I uploaded. So just the steps, and if you like, for you, you will just read the question and check if you can understand the topic and everything. And if you want to get some extra credit, it's not mandatory, but if you want to get some extra credit and you know that helps, all these practice problems due tomorrow by 5 p.m. Okay. And you also know you don't need to submit all the solutions. If you can solve one, just submit that. If you can solve half, just submit that. You will get some points, right? Okay, so that's what you will do, and I request you to do that. And yes, I haven't uploaded anything yet, but you are welcome to bring your equation sheet or formula sheet during the test. Okay. Yeah, just like the previous time, just all the equations. You may want to write the abbreviation also, like what is P, what is R, something like that, but no concept, no solution of example. Yes. That is my plan. I will try to do something by tomorrow, but I'm not promising 100%. But I will try to do that. That is on my to-do list. So you may wait till tomorrow just to prepare your equation sheet. If I don't upload anything by tomorrow 5 p.m., which is the practice problem due time, I think it's better if you prepare your own. Okay, does that sound good? Okay, so so far for last 4 weeks we have covered hydrologic budget, probability, and precipitation. So 3 main topics, and under each topic we did something. Introduction, we did some problem, we discussed some conceptual thing and everything. In total, your syllabus is from lesson 1 to 10. This today is lesson 11, or it can be 10, 1 to 11. You had 2 homework, 1 and 2. One was about the probability, one was about the precipitation, and project 1 was all about the hydrologic budget. So for hydrologic budget for project 1, that was kind of, there was no exact answer, obviously, because each of you chose different area and everything. So from that part, maybe I can ask some conceptual question or something like, okay, for July, why the rainfall, the precipitation was less than that, or something like that. Okay, so that can be project 1. So allowed to bring, obviously, please bring your calculator. I will not allow you to use your cell phone as a calculator. That's a no, no exception. So bring your calculator, a working calculator, multiple pen, pencil, eraser, whatever you need, straight edge. Equation sheet, as I said, my plan is to upload something within tomorrow. For any reason, if I can't, maybe I'll email you and prepare your own equation sheet. We have only 3 topics, so it shouldn't be that long. Okay. Okay. Then the question format will be just like all the other exams I usually do. You will have some multiple choice questions. By this time, you already know what is FE, right? Most of you are in CE 416. Okay, so if you like, there will be some multiple choice questions. If I like, if you can give me the correct answer, you'll get points. For wrong answer, there is no partial point. Again, there is no negative point as well. Okay, so mathematical problem and some conceptual thing maybe. There will be few from each topic. There will be at least 1 question. So don't skip any topic. That okay, I will do better on the other 2 topics. Don't do that. There will be questions from each topic. And from the extra credit questions, you know, if you can answer, that's great. If you can't answer, you will not lose any point. So that's the thing. Now, as I said, I will go through very briefly, not with exact calculation, rather all the steps. about all the practice problems. So in total, I gave you 7 practice problems, okay? 3 of them are kind of connected with each other. You have a big data set for question number 1. And from that question, question number 3 and 4, those are connected. So let's go through very briefly, and in between this process, if you have any question, just stop me and ask me that question, okay? Okay, so for the first one, the question was determine the sample statistics of annual rainfall for the records shown in the table below. I didn't attach all the tables, but you have that on your practice problem. Now, when I say sample statistics, it can include at least 4 things, okay? The first thing is mean, okay? There can be different types of means, but here we only did the arithmetic mean. So I will just write down that one, X bar, okay? What is the second one, right after the mean? What is another very common thing for standard deviation? Yes, that's correct. Which is S. Then there can be few more. The next one can be, yeah, so the coefficient of variation, this one. Okay, which is CV, and at the same time, it's the ratio between S over X bar. Another one is coefficient of skewness, okay, like how skew one data set is, and this one is A over S Q, okay. Now, if I say very specifically calculate the mean or standard deviation or CV or CS, you are fine, you can calculate that. If I don't mention anything, you need to calculate all 4 of these, just like this question, like sample statistics, okay? So now the question is, how can we calculate that? We kind of know that, but I will just write down the equation very quickly so that you have everything on the same one place. And one more thing, if you want to submit these answers for like extra credit, I think it's better if you do all the probability question on Excel, because you will have the same calculation and there is no point of using like hand calculation here, okay? Now, for the mean, the equation is obviously it's the arithmetic average one. You can do that by Excel, but I am recommending, since during the test you will not have access to Excel, just make sure you know what is the equation and how to use that, okay? So for the nx, this one is 1 over n, summation of all the x, that is the mean, okay? For the standard deviation, we can't calculate the S directly, but we can calculate the square of standard deviation. So which is square 1 over n minus 1 square, right? Now the coefficient of variation is obviously S over X. If you can find these two, you can find that. Now coefficient of skewness, this one is again standard deviation, but we need to calculate the A. Now how can we find A? N minus 1, n minus 2, is 1, right? Now every time we are seeing something n means what? N is actually what? Number of samples, yes. Or size, sample size, something like that. Okay. So you can do that for question number 1. Yes.
So it says, after this table, what table?
It is actually attached on your like original practice problem. A set of data there. I think 23 or 30 data points there. Okay.
Oh, so you just want to see, example one. Is that what you're asking?
Say it again.
Well, so number 1 says, the sample statistics for the table below, but there's no.
Because I didn't add the table there, but if you go through the canvas here, like the main practice problem, you will actually see the table here.
Oh, so it's on the campus.
Mhm. Yes, yes. Let's check where is, I uploaded that. Here, practice problem for test 1. So if you just upload that. So it has all the tables and everything. Here,
Oh, okay.
okay? And that should be the answer. Okay? Okay, so your question number 2, I will do that later because 2 is not about this data set. But question number 3 and 4, it's all about this data set, and that's why I said from previous example. The previous example is actually question number 1. Okay. Okay. To read the question number 3. Quickly, we need to do that quickly. Mhm. Thank you very much. So here is the same data set, and this time we know the normal distribution. Okay, we know that distribution is normal. Now, do you remember that we discussed a little bit about different type of distribution? What was the most common one? The normal one, and the shape of that curve is what? Kind of that bell-shaped curve, right? Okay, so for any kind of distribution, if we want to do the distribution statistics, it was kind of x equals to x bar plus k multiplied with standard deviation, right? And we also discussed that k can be different for different types of distribution. So we actually need to know the distribution type. And here, do we know the distribution type for this problem statement? This is the normal distribution. So for normal distribution, yes, exactly. So for the normal distribution, the instead of k, we use z multiplied with s, right? And for z, usually we have a table B1, right? For different type of distribution, we have different tables, but the normal one, this one is table B1, and x bar and s. From where we will get that? Do we have x bar and s and everything here for this question? Where? Question 1, right? So from question 1, we already have the x bar and s, and we can find the z from table B1. So you can actually calculate the s. Yes.
So what's the difference between the two equations?
This one is the kind of the general equation, okay, general expression. And this k will be different for different type of distribution, okay? Now, if you remember, we did one class example in the class where we didn't know about x bar and s, but we have two data sets there. So please make sure you go through that class example also. Here we already know, so this one is kind of easier. Now, do you want me to go through how to calculate z? Okay, so for z, we said that we will use this table, right? Now, maybe you can't see that clearly from your sheet, but your copy has this table as well. So all the value here, they are actually a z value, right? Yes. It's not exactly probability here. For this one, it's 0.5 minus that probability, because if you look at the table, yeah, this is kind of probability. That's correct, yes. So that Fz is 0.5 minus Pz. That Pz is actually the probability here. Okay. There is another type of table exactly for this distribution, but their range is from like 0 to 1. That time you can directly say Fz equals to probability. So you may get confused, but this time we are using this one. Okay. Okay. No, because I didn't go through that table. It's the same thing. Here, if you look at the very high, like the highest range is 0.5. For the other type of table, the highest range is 0.9999. So instead of, if you look at the table, it's going to both directions, the 0.5, 0.5, they actually start from 1 end and go up to 1. So that's why that one is a little bit different, but since your book used this one, I thought I will use that one as well. Okay, so probability is what? 1 over. Now, do we know the return period for this question? What is the return? 200 years. Okay, so you will have some FC. So what will be the FG? Can you give me that number? .4. .95 or something. Okay, now 0.95, we said that all of these values are FZ, but we need to find exactly 0.495, right? So 0.495, how we will find that? We need to find, okay, which one is the closest to 0.495, right? So let's check here. Do you agree these two are the closest for 0.495? Okay, so I didn't write down the interpolation equation. You need to help me on that one. What is the interpolation equation? The linear interpolation equation. Do you have that on your copy? Y equals to something. Y x1 or y1? X1? I forgot the equation also.
Plus x minus x1.
Okay.
Y times y2 minus y1 over x.
Okay. So that is the linear interpolation, right? Now, y is the unknown, like general unknown. In this case, this is actually the z, right? Y equals to z our case, because z is the unknown here. So we need to find out which one is what. So x, we already know x is 0.495. For this one, we want to calculate this. X1 will be 0.4951. Now, what is the z value for the first fz? Do we remember how to find the z value? So 2.5 plus 0.07, which is 2.57, and the next one is 2.58, right? Now for this one, that 495 is exactly at the middle. So even if you don't do the interpolation, you know what will be the answer, but you may not become that much lucky during the class. Maybe I will give you something where you need to do the interpolation. Okay. So make sure you write down the interpolation equation, or you know how to do the interpolation. So if you do the interpolation, I think you will get not point, 2.575, I guess, right? So that is the Z. And if you have that Z, you kind of know what will be the X, right? From the previous equation. Are we good up to this point, everyone? This is exactly the same. I think it's directly from your homework, I guess, because it seems familiar, but I'm not 100% sure. But please go through the other example we did in the class where X bar and S was unknown. Okay. Okay, are we good up to this point, everyone? So if you want to submit this one, you can work on that. Okay, great. So the next one is question number 4. Again, it's very much related to the previous example, question number 1. Okay, so it says that using the 23 years of annual precipitation depth for one of Virginia, estimate the exceedance frequencies and the recurrence intervals of the highest 10 values using the Weibull equation. Okay, so the recurrence interval is T, exceedance frequency is P. Now, the thing is, you need to find highest 10 values. Okay, and you have 23 years of annual precipitation, so that is actually the N. Now, we discussed how can you sort out the data using Excel, right? If you have 500 data or something, there is no point to go through manually. But for these one, we have 23 years of data. If you want to use Excel, that is fine. If you want to do the sort out manually, you can do that as well, right? So you just need to make sure you know how to sort out the data. You need to find highest 10 values, and like for each one, you need to find P and P. Since we need to find the 10 different values, it's better to work using a table. So very final one is T equals to 1 over P. Now the next task is, it says that using the Weibull equation. What is the equation for probability in that Weibull equation? M n plus 1, right? Now the question is, how can I find M? What is M? Anyone remember? Rank, yes. So now the question is, what is rank? Rank means when you choose that 10 highest values, you will just rank them. The highest one will be 1 and the lowest one will be 10. That's the thing, right? Now, there are few things. Okay, maybe this is the year, this is the precipitation. Okay, so I don't know what will be the result you will find. I'm just using some arbitrary value. Okay, so 1991, 7, 8, 1989, 1972, maybe something like that, right? And for each one you have some values. So suppose for this one you have 4.3 inches, and then 3.7, 3.7, 3.7, and finally you have 1.8 inches. Now, one important thing about the rank, okay, don't get confused with this number. These are just, I made up these numbers. So when we go through about these numbers, don't freak out, okay, from where I got these numbers. Okay, so the rank for the very first one will be what? 1. Now I have 3.7, 3.7, 3.7. It will be like if I did traditionally, it would be 2, 3, 4, but I can't do that. I will take the maximum one. So my actual rank will be 4, 4, 4. Okay, that is important. That was the important part. for this question is how to select the rank. And once you have ranked, the rest of the part is easy, right? Okay, great. So now we can go back to question number 2. Okay, we still have time. So question number 1, 3, 4, those are all about the same data set. Okay, so are we good, everyone, up to this point?
So it's T, is that what you're calling for?
T and T, yeah, because T is the recurrence interval, which is T, and the exceedance frequencies is actually the probability. So, like in test, I may only ask you to do the P, maybe not the T. But if I ask you to do the T, you need to do the P actually, because T equals 1/P, right? Okay, so let's go back to question number 2. Is one. Now, the annual records of 5 precipitation stations are given. Check the consistency of a station A. Adjust the record if it is inconsistent. So again, in your extra credit, that question set, you will have all the data set. I didn't have any data set here. Suppose you have 5 precipitation stations. So I'm assuming you will have A, B, C, D, E, right? Now, it says that check the consistency of the station A. That is task number 1. Now, if you find any inconsistency, you need to adjust that. That is task number 2. Now, I may mess with you during the test. I may give you a perfect set of data without any inconsistency. Then you don't need to do the task 2. Your only task 1 will be, you will plot that. And if you see there is only one slope, you will just say that there was no inconsistency, right? So you may have one task or you may have both, task 1 and task 2. Yes.
I know when we do it on Excel, especially on the class level,
Hmm.
it's kind of hard to visualize the different slopes.
Yeah.
Is it gonna be like very apparent on the test?
Kind of, yeah, like you will kind of know that if there is an inconsistency. And I'm telling you 90% possibility that you will have some inconsistency. There is only 10% possibility that when I prepare the question and either I'm in a very bad mood or good mood, I don't know, I may just say, okay, I will not give any inconsistency, I will give perfect set of data. But you can expect most of the time there will be inconsistency if I ask you this question, okay? So once we have that, the task is, what is the best way to check if there is an inconsistency or not? We will plot 2 sets of data, right? So here it will be accumulated data for base station. Base station means for which station we are doing that. Here is station A, right? And on the other side, since I'm plotting all the other 4 stations, I can't take all the readings. It's just I need to take the mean, right? So it will be accumulated mean data. That should be precipitation actually, the data for surrounding state. Okay. Now this word is important, the mean. You need to find the mean for all the other stations. Don't just add and plot that. Okay. Just mean. Okay. Now you can have 3 different scenarios. You can have perfectly this type of line. Okay. That means no inconsistency. Okay. Great. You can have this type of data set, or you can have this type of data set. Okay. That means there can be a break in the slope. Now, Whenever there is a break in slope, you know that there is inconsistency. So the answer is if there is any break. Inconsistent. Right? Now the task 2, once we know the data is inconsistent, we need to fix that. Now there are multiple ways to fix that. One way can be we already know which data set is the problematic one. In that case, task is easy. If we don't know which data set is problematic one, we usually go for the larger data set and we want to fix the smaller data set. Okay, so I will just write down 2 points, and if you think I need to write down more, we will do that. So this is the A, this is the B, this is the A, this is the B. Okay, and all the time here C, C. Okay, now one way, adjust the data set based on recent trend. That means you want to reflect the change reflect the change of the recent trend to the older set of data. So the adjustment factor will be B over A, because B is the recent one, right? Another set can be adjust the data set based on older trend. Then the factor will be what? A over B, right? Right. If you want to change, if I say, okay, this data set is the correct one, obviously I want to fix this data set. If I say, no, this data set is the correct one, I want to change this data set. So whatever the correct set of data, you will multiply, like that one should be on top and the other one should be on the bottom, just like here.
So B over A is to fix A.
Yes, exactly. Yes. Now, for any reason you don't know which data set is the problematic one, we will always go for the, like what we always want to adjust the smaller data set. Okay, so I will just make that note. If we don't know which data set is the problematic one, we will always adjust the smaller set of data. Okay. Does that make sense? Most of the time you will see like you will have a small set of data and then a bigger set of data, and you kind of know that, okay, which data set we need to fix. Okay? And sometimes maybe I will kind of explicitly tell you what to do. Okay? Are we good up to this point? Okay. Please just remember you will not have no Excel access to the test. So make sure you know how to calculate slope, how to do all the calculations. Okay. Okay. Now we have few more. I think this question is okay. Read the question and tell me from which part this question is, like from which topic. It's the big question statement. Yeah, read that. Okay, someone from the last row. Read the question. Uh-huh.
That month, the lake received an aggregate for its
Uh-huh.
from service. Outflow, average value of 6.9.
Okay, there is one mistake that should be meter cube per second. Okay.
Further, that month, the lake received a rainfall of 150. Like the water budget. With the water budget was some- Like, so there is 1,000.
Hector, yeah.
Assume that there is no contribution from water source.
Okay, so is it from the water budget? Is it from the precipitation or is it from the probability part? Water budget, right? And if you can remember all the class examples we did, I told you it will be a mess with all the units. And you can see that here as well. That one of the challenges you will face for this type of question, just to make sure units are consistent. That's what we will do. But what they are asking you to do, you have a lake with 5,000 hectares of area. There are some input, there is some output, and the difference between input and output is what? Storage, right? So they are asking you to do, you have a lake. Suppose this is the lake, okay? This is the water surface, and the elevation is 103.2 meter at the beginning of the month. And you are asked to find what will be the elevation of that lake at the end of the month. Okay, so the delta T is what? Like the time difference is 1 month, right? Is that correct? Like you need to find the here lakehead water surface above at the beginning of a certain month, and in that month lots of things happen. You need to calculate the water surface elevation of the lake at the end of that month. So the delta T is 1 month, right? Now water budget equation, it was input minus output equals to delta S, right? And most of the time, the storage, we actually calculate in terms of volume, right? Most of the time. But you need to calculate the surface elevation, which is kind of depth. Is there any way you can change the volume, or you can convert the volume into distance or depth? What is the way? Divide by the area? Does that make sense? Do we have the area? Here, the area is fixed, so it will be kind of easier if for any reason the area was not fixed, that then it would be a problem. But here we already know the area is what? 5,000 hectare, right? Okay, now I didn't give you the conversion factor. 1 hectare equals to actually 10,000 meters square. Okay. Okay, now let's find out what are the inputs and what are the outputs, and then we can find the delta S. Okay. So what is the very first input? Okay, we have kind of 12 minutes, so I'll spend majority of time here, and then for the next two, I'll just go through very briefly, okay? Okay, what is, that should be O, yes, you're correct, that should be output. Okay, so what is the first inflow? We have 6 meter cube per second. Okay. In the same period, the outflow from the lake had an average value of, is that inflow or outflow? So it will be 6. Okay. What else? In that month, the lake received a rainfall of 145 millimeter. Is that inflow or outflow? 145 millimeter. And the evaporation from the lake surface was estimated as 6.2 1. Is that outflow or inflow from the outflow? Okay. Okay. And you are already seeing we have a chaos of all the units, right? We have meter cube per second, we have millimeter, we have centimeter, we have hectare. Okay, but we will work on that. Now, the question is, we need to convert everything into SAM units, right? Some standard units, or either it's volume or something. Since we know the time is 1 month, and here the time is in second, if we multiply this whole thing with some second, we will get the volume, right? Does that make sense? Okay, so if we want to convert 1 month into second, we need to work on that. 1 month equal to 30 days, right? Each day is 24 hours. 1 hour is 60 minutes, and 1 minute is 60 seconds. So that will be something second. I don't know what will be the answer, but it will be something. Okay? So if I want to convert everything into volume, I will multiply with delta T. I will multiply with delta T. Now this one is 145 millimeter. I can't work with millimeter. What I need to do? Divide by 1000. Now it will be meter. I can't work with centimeter also. I will divide that by 100. Now even if I divide by 1000 and 100, still it's not volume. Still it's just the gap. How can I convert that into volume? Do I have any area or anything? Okay. So I have the area which is 5000 multiplied with what? 10,000 meters square. So I will just name that as A. Everyone, does that make sense to everyone that what we are doing? As I said, for this type of water budget, the main thing is to identify which one is input, which one is output, and then just the unit conversion. Okay. So once you have that, I don't know what will be the number. You will have a delta S something meter cube, but we can't work with meter cube for surface elevation. So what we will do, I will just divide that meter cube by area, that will be in meter, right? And if it's positive, that means surface elevation is increasing or something. And if the delta S is negative, that means surface elevation is decreasing. So what you will do, the very last line, elevation at the end of the month is 103.2 plus delta S. Whatever is positive, negative, whatever it is, it will take care of it. So that is question number 5. I have only 6 minutes. So I will go through very quickly with 6 and 7. But 6 and 7 we did recently, so your memory is kind of fresh. So I think it will be okay. So are we good up to this point, everyone? Okay. So, and since I'm recording that, if you have any question, you can always come back to this one. I will release all the videos. Everything is on my canvas. Okay. So the very last one, a rain gauge located. So the main thing is we have these sessions here. You need to calculate the precipitation using the freeze and collision method. Okay. So here, how many stations we have? 8. Okay. So what we will do, if you can remember, the very first step was connect all the adjacent station using dotted line, right? So that's what we will do. Okay. Connect all the adjacent. Okay. And the next step is you will draw what? Perpendicular bisector, right? Do you remember that? Okay. So I will write down the perpendicular bisector for this one, for this one, this one. Then I will draw for this one, this one. Something like that, right? And if I just consider one area for station B, that is the area I have, right? Does that make sense? Okay, so this is the very final solution I have. If you look at my copy here, just look at here. Your final drawing will be something like that, okay? Just like that, kind of spider web, okay? Okay, so the very last one, exactly 5 minutes. Okay, now for question number 7, I kind of challenge you a little bit. So for this one, you need to think a little bit for the very last question. But that will help you to understand better. So the very last one is this one, S1, S2, S3, S4. Now, if you remember in the class, we had kind of easy rainfall measurement like 4, 4.5, 3, 3.5, kind of round number. But here, if you look at the number for S1, we had 4.6. For S2, you had 5.2, you had 3.8, and for S4, we have 4.5, right? That, right? Now, you can do that exactly whatever we did in our class example. That is one way. I did another way for this one only. Instead of using all of these like 4.6, 5.2, I kind of found all the round number like 4.5, 4, something like that. Now, how to do that? Obviously, the very first step is same. You will connect all the lines, right? If you want to connect 4.5 and 4.6, you can do that, but it's almost same. Now, in between 4.6 and 5.2, what I did, I tried to find where is 5, where is 4.5. Okay. In between 5.2 and 3.8, I tried to find where is 4, where is 4.5, where is 5. Okay. In between 3.8 and 5.2, you can measure that and you can find where, yes. Oh no, 4.6 is the point here. Oh, you are correct. No, yeah, you are correct. Yeah, there will be no 4.5 here. 4.5 will be this side. There will be only 5. Yes, you are absolutely correct. Okay, we have only 5 here. In between 4.5 and 3.8, we will have kind of 4, right? Now, once I had that, then you will kind of add all the 4. If I use a blue color, you can connect, but it was in like 4.5 and 4.6, which is kind of same, but you can connect that. Okay, class, can I have just 1 more minute? Okay, so you will do 4 and 4, and then I connect 4.5. Oh, here you will have 4.5. So I will connect 4.5, and then I connect 5. So I kind of did that way, but you can also do whatever we did in the class example as well. Okay? And once you have that, then you will do number of polygons, and then you will multiply with whatever area, something like that. And finally, P1 will be right. So that's what I did based on the isohydral method. Try to do that. If you can do that, that's okay. You have, like, I will upload the solution and you will have the solution. But try to find if you can get 4.5 or not. Okay. Are we good up to this point? Okay. Everyone, good luck. I will see you on Wednesday.